Hello, we're going to have a look at the SLAT component, which is right here, the SLAT machine. So assuming that this is our site, this polygon there, I'm just going to drag the SLAT component and disregard the defaults as I normally do. The first thing to do is to extract the parameter of the boundary by typing right-clicking extract parameter to create a brand new component, and then assign one curve, which is the one that I had highlighted, which is my own site. So you see it's automatically updated. And the next thing to do is to very quickly run through the parameters. The first parameter to look at is the number of columns. Let's assume that these black stripes are the columns. So this is just an integer, so we could just create a slider from 0 to 20 and route that into the columns. So you see we can go from 5, 6, 7, 8, however many. The next thing to do is to set the absolute dimensions of these white stripes, which are named wall. So you can also create a string of integers from 0 to 20 with a non-zero value, route that into the wall, and then you see we have a variable width for these interstitial spaces. The next thing we have is the scale, which is a percentage of the site that we're actually using, you see. So that is a percentage. So I'm going to create a slider, a real number between 0 and 1, right here. And route that into scale, and then you can see that we can use 100% of the site or just bunch them up in 1/4, 1/3, 1/2. So I'm just going to put it right there. And of course, the most obvious parameter is the actual rotation about the centroid of the site. That would be an integer between 0 and 360, which allows us to redirect these stripes as needed. So I'm going to stop there. I'm going to decrease the number of columns, increase a little bit their width, just about this. And then that's it for the parameterization. So let us see what we have created. So the output, let us create a curve component to collect the output. You see, it's right there. You probably can't see it. It's this green outline. Let us extrude it using the extrude component. And let us create an extrusion vector this time. I'm going to type Z for extrusion vector, put it right there, route it into the D, and you see it's still only 1 unit high, so you need to create a coefficient for the extrusion vector. So let's say anything from 0 to 100, right there, and then route this in, so we have now an extensible height. So we can actually do the same for the so-called walls, which are the interstitial spaces between the fingers that I have just created. So I'm going to make another curve right there, collect that particular outcome, and then extrude it as well, but by less. So I'm going to type a brand new extruding component, route the geometry, and I can select this, copy and paste, move it out of the way, and then simply just use it, but of course change the actual magnitude of the vector so that we get something which is more like this right there. You see it? So of course all of these games now are contingent on us of course continuing to tweak the parameters. So I've just modified the width, you see, the actual angle of rotation about the centroid. And now that I have this, I can also change, for instance, the width of the walls. And I'm just going to extrude it so that we can see what the outcome is. So I have 2 different sets of geometries, the fingers and the so-called walls. I'm going to create a single geometry component and collect both outputs. I'm going to make sure that I cap it by typing CAP to cap hole, and then collect that single output, and then of course bake it right there. turn Grasshopper off, change the display to Arctic, and look at the results. So you see it's following the boundary very, very closely with all the parameters that we've entered.